Okay, so it looks like I finally figure out how to properly use H and X. Really, I was using it so badly. So I did a bit of extra coding yesterday that I didn't manage to record because of some technical issues. But um, I've basically simplified that a lot. It's just like these. It used to be like a huge function. I just basically realized that actually nodes are entities, right? And so these entities can have properties based on the on you know what I read in here. And so what I'm doing is I'm not like encoding or decoding the state as sort of a unique identifier, but I'm using the this create node function, which is it creates an entity with a unique ID, and then it adds the state vector as a state property of the node. And so I don't have to care whether they are unique or not and all this kind of stuff. And I can just go ahead and um, also just do like that, right? So access the elements of the system, which are which are the nodes of the edges, sorry, and then iterate over them, and then just do the dot product of the gate, and then so that just get the state like that, right? And I don't even have to reassign. In this case, it's just like I just update the nodes, right? So that becomes much more easy. So what I want to try to do today is finally just get this one properly done from scratch, the control gate. And so, I think I'm just gonna go and like start from scratch, literally. Um, what do we want to what do we want to happen? So we have several scenarios, right? We have the scenario where um, there's no entanglement edge, and that should be easy, right? Because I mean that's basically I think what I implemented last time. So I have a control qubit, I have a target qubit. So to some extent, what I should do is I have to find the control qubit. The problem is if there's no entanglement, like if I wanna really be because do we want to support mixed states, right? Because to some extent we do by default, right? By the fact that we can have multiple nodes as part of a qubit, like it means that it can be in one of those states, right? So it's a mixed state to some extent. Um, that really is what entanglement boils down to at some point. But so what I'm sure that's going to happen is that the target nodes need to be duplicated, so they need to be cloned, and I need to apply the gate to those. So this is something that I can definitely do. Now, those won't be associated to the same node anymore, so this is something that needs to be um, but everything else from those nodes must stay the same. So I really need to clone them. So I think regardless of that, this is something that I have to do. I have to get the target nodes. So I get the T nodes, target nodes, because I know I'm going to ask what is these, and I get from the target edge, I get the elements. And what I have to do now is I have to just clone them, right? Because I have to apply the operation. So only for the case where, I'm creating two branches. In one branch of the world, I'm not applying the operation. In another branch of the world, I'm applying the operation. Um, and this is just one control gate, okay? So we're not dealing with multiple control gates here. So how would I call that? So I need to clone them. So I need to have like, well, target node 0. I think I like that. Like the way to name it, right? Like these will be the ones where I'm gonna apply these. So what I need to do is can I mass clone? I cannot mass clone, so I probably have to. So I probably have to loop through those. I have to say for target node for Tn in target nodes. right? I want to do target node. 0 is target nodes. Because I think I'm getting, because it's a dictionary, I think I'm getting the sort of the index. And now I want to do the target node 1, which is basically it's just basically a clone of these. And I need to give it another I need to give it another UID. I think that's the way this worked. What I need to do is I need to apply the operation to these nodes. I need to say target node 1 state equals, and I do these, right? So the state of it multiplied by the gate, and now I have applied the operation. Apply the gate. Those should be removed from. No, those should still be. Now here's the trick, right? So I have a node. So what happens now if I have multiple control nodes, right? Because essentially I gotta remove these target node. Well, and now I have to basically have, of course, target nodes 1, and I just have to append target node 1. I mean, I don't know if I need that, because to be honest, I'm just cloning that, so it stays everything there. That's all good. But what I need to do now is I need to go and take a look at what I do in the control. So, and this is where it gets complicated, because now what I have to do is I have to say, okay, so do I have one node or do I have multiple nodes? If I have one node, it's easy, right? I need to just check, is it 0? Is it 1? Effectively, I think what I have to do is I have to run these for every node, right? Yeah, of course I have to do this for every node in the control. So really, I really need like a control nodes, okay? So target nodes, control nodes. That's going to be definitely a nicer way to implement that. So this is going to be control elements. Cool. And so what I need to do is I need to do a for control node in control nodes. All these, of course, just kind of goes in. And so what I do now is control node. So control node. Now I need to figure out whether do I split these or I don't split these, right? And regardless of these, I think the best approach would be, I mean, if I don't need to split these, right? This means the control node is either 0 or 1, still need to have the edge created, the new edge created between the control and the target. Essentially, I need to create two edges out of these. That's the whole point. How am I gonna do this? Am I gonna create entity groups? Because the hypergraphs here are just, I can hypergraphs. Add edges. Add edge. It's an entity. Entities. Can it be an entity group? Yeah, I guess so, right? An entity set, sorry. Okay, but it's an entity, right? So I need to create two edges, right? So I need the edge 0, which is basically an entity, an entity set. We'll also use these, and then the edge 1. Exactly. And so now the question is, do I need to create one edge 0 and 1 per node? This is what I don't know. But I would assume so. I mean, anywhere where I'm probably going to assume, we'll first assume, okay, we got only one node. The problem is what happens when we got more nodes. What do we really do? I think within each node, that's what we happen. That's what would happen. Like you just go to each node and you either split that or not. So really, that actually happens. That actually happens inside these for loops. So now I'm here and I have like edge 0 and edge 1. And so the control node is basically control nodes CN. Now I need to decide, what do I do? Do I split these or I don't? And I just, to be honest, that's all I need to do. Then these, we're literally duplicating the entire target set. Okay, but that's dangerous because for the odd nodes, I don't wanna. For the other nodes, I don't want to copy the whole thing. You just have to copy the original target nodes. But I think that's fine because I'm fetching them here and then I'm iterating over them. So I think that is fine. unless this is somewhat like reference instead of a value. So, no, I guess that's not a reference because I'm literally getting the elements. So that should be fine. So I think that is good because I'm just like kind of creating. So for each one of the target nodes, and now what I should do here is I apply the operation. I should actually say h0, just add element, or add element item. So add element target node 0 and edge 1 target node 1. I think that's what I should be doing in here. So I just should add them to the to the corresponding edges, and now I just need to add the control node. So there are two cases. So now I really should do an if, I think. So so I think if what I basically do is I'll just calculate whatever, I don't know, I'll call it P, but I think what I should do is the way I was doing it before, I think it was like that. State real plus this whole thing again, but like Emax. So if these basically, you know, if P what do I want to check actually? If I want to check if it's a 0 or if it's a 1. If it's a 0, it's going to have like a 1 in the real. Like, oh, sorry, that's actually, the state actually has two complex numbers. Yeah, so I got to check whether, you know, if which one is 0, and if none, exactly. So the state state 0 and state 0. So exactly. So this is sort of the probability. This is probably not the probability, but like whatever, the probability of the 0 component. It's P0 and this is P1. And then I'll just do P1. So this is not the right thing probably, but I just, you know, if those are the only way these are 0, if the both things are 0. So if P0 equals 0, right? Then we've got the case of you know, then what we do is H1 on the element the entire control node, right? Now elif P1 is 0, then we add these to the edge 0, right? Because it means, yeah, exactly. And now else, we gotta split the whole beast, right? And here we know what do we do with the probabilities, though. What do we do with the probabilities? Because they should, I think they should stay somewhat in the edge. And now that I know that I can add properties, I can also put them in there, right? So we can. Do we really need the props in the edges? Probably. So what we should do now is we should do the following. So what we do is we do we put the complex number in there. So what we do is we say edge 0. I'll call it I'll call it amplitude. Edge 0 amplitude. It's not super happy to use these here because it's not really an amplitude. It's really the amplitude what we're doing, but it's not really like what I. Well, I guess we do this regardless. Like we don't do this, you know. I think we just do this here anyway. So we just say, you know, that's the way these edges need to be created. So the edge 1 amplitude is the control mode state 1, exactly. And I might just as well do this right away. Can I just yeah, I think I can just do it like that. The same way that I did it here. So I can just say is an entity set. I think I can just do like that. And well, I probably what I should do is get node levels, and I want to do also get edge levels because I want to print those probabilities in the edges as well. Labels. Edges. And I do amplitude. So get no labels. This is what I'm passing the this is what I'm passing to the function in here, no labels. And probably I just should call these edge labels. I think that's the way I think that's how it's called. And so it tells the draw function what to print as labels, which is basically sort of the properties that I'm putting in the entity. That's what I was getting wrong completely. Okay, so but now we have good. So what do we have now? So we have for each of the control nodes, we create 2 edges. We get the control node. The 2 edges have like the control node needs to be here, otherwise this is not going to work, obviously. So I'm getting this and I put it as an amplitude of the edge. Then I get P0 and P1, and then I just decide, okay, so this element goes directly here, directly there, or else I guess, or else I need to split this node. And what this means is that I need to create so I need to clone. How do I do? I need to clone this node probably because I want to carry everything with me. So I need to do the control node 0 is control node. Control node 1 is control node clone get UID, right? What we should also do is we should change the state. Basically, this should be the 0 state, right? Which is this. And they should be these basically. And what I should do now is I should just add. You know, this one to the edge 0, this one to the edge 1. There we go. Is that it? So I've split the node and I just added them to the proper places. I just need to, yeah, the amplitudes have been set. It's all good. I almost feel like, actually, do I even need to do that? I don't need, because I just like, no wait, I do need to do that because I don't have to create I don't have to create another one. So in these cases, I just add it to one edge or the other. Okay, but then the whole thing about applying the operation only happens it only happens if I'm in it only happens if P0 is 0. Then we just apply the operation to okay. So I think that is there must be a way to make that a bit more, write that a bit cleaner way. So if I'm in here, I need to take the target node for each of the target nodes, get the node 0, clone it, make the sort of operate on it, and then add both elements. Well, I think I can just basically say that so if P0 equals 0, we know that we just so I gotta use these P0s again. So if I say if P0 equals 0, blah blah blah. So then we know that it's a 1, and so we have to apply the operation to the target node. So this target node, which I'm going to fetch in here. So the only thing that I need to do is I need to do target node 0 dot state equals this whole thing here. So I'm applying, I'm not creating, okay, I will be creating a branch. But I'm not so sure if this branch won't just get cleaned up later on anyway. So if P, so L if P1 is 0, it means that it's a 0. So in this case, kind of like nothing happens, right? We the operation. We apply the identity. We apply the identity. So no operation. Not target node. Yeah, target node, sorry. And we add that to the edge. To the edge 0, right? So I add that to edge 0, target node 0. So if probability of 1 is 0, for the to edge 1, sorry. So I don't have to clone it because that node so for each node I need to take a look at the original target nodes. Shouldn't I just kind of create a copy of these as well and not just and like never do it like these? I'm probably just trying to overthink these too much, but like if target nodes is always going to be the original ones, and so what I'm doing is here I'm just like getting the getting that target node. I suspect this is all references stuff, so I'm just going to be modifying these, and then for the other cases that won't work. But let's see. Pause for a second. Okay, back. So, getting the target node. Not so sure if this is gonna work because I'm not really sure how this is all implemented. I'm just afraid this is all being, just as references, and then so whenever I modify these, I'm just messing up with the next iterations. But we'll see. So if p0 equals 0, then it means that it's in the 1 state, and so then it means that I can just modify the target node 0 state and add it to edge 1. Exactly, and the control would have been added to edge 1 anyway. And then if p1 equals 0, it means that it's in the 0 state, and so what I should do in this case is I should not attach target node. And just add it to edge 0. Else, and I think it's basically everything else that I have here. So else, I need to create a target node 1. Cloned. I need to apply the operation, and then I need to add both target node 0 and node 1 to the proper edges. Okay. This could work. So I get the target nodes and the control nodes. I start iterating on the control nodes. For each control node, what I do is I create 2 edges, right? I just do 2 edges, and so then I just basically, you know, process control node, target nodes. Because for each control node, I need to go through all the target nodes. Which I'm just getting outside here just so they are the same, and I don't account for the stuff that I'm adding here. That could work, but I haven't touched, and I haven't really been playing with this while I build these, so I think this just goes away. I don't think that's gonna work. That's gonna break. Well, for sure I need to run this one first. So I don't use encode state anymore. I think I can get rid of these. Well, I use it all over the place here, but I don't care because that's just wrong. And I also don't use decode. That's beautiful. Cool. Well, yeah, of course it broke. I'm gonna delete these cells. That's just crap. Cell. Edit. Delete cells. Non-types has no attributed amplitude. Oh, sorry. This is not amplitude, okay. It could be that these are so should I create this Q0 and Q1 as like like hypergraph from a dictionary of iterables? I guess I can just do it like these, right? So I can just do it like these. Create the entities. That entity set. So I can just create like What does create node? It just does these, right? Oh, I can just create an edge, maybe, right? Create qubit edge. So this is qubit, and this is basically, that's all I do is I just use this as a UID. It's empty, and it's got amplitude of like non-applicable or just empty. Exactly. Create qubit edge. Return edge. And so what I should do is I should probably do Q0 is create qubit edge. Q0, Q1, create qubit edge. Q1, and then I just can I just do like, oh, and this should just initialize already. It should actually, so the edges create the qubit. So this should actually create the edge, have the initial state in here, and then say, well, basically, the initial state would be here, and we would just create one child with initial, yeah, so that would create the node in here. Exactly. And then we would just return the edge. I think that makes sense. Create qubit edge. And so all these does is it creates qubit 0 and qubit 1. And then it gives these in the hypergraph. What? Okay, let's first from state vector. Okay, so what is going on here? Maybe let's just get rid of these for a second. Q0, Q1. Okay, so that at least explains the labels. Ah, so I can just I can just say edge labels. It's basically n, right? I think that's what we want. Exactly, so at least it prints. Oh, look at these. It actually worked. What? Really? It actually created the thing? I can't believe that. So it actually created the... No way. Okay. They're both in zero state. If I apply just a single X gate. Now that seems to work. If I apply it to Q1, that seems to work. Wow, okay, cool. Now I want to apply a hardmode gate to keep it 0. And now I want to apply, let's see if it works for this case, okay? Like if it works for this case, I'm gonna call it a day. Then we're gonna test other cases later. So control on Q0, target Q1, and I wanna apply the X gate. So that's like a control. That's a control gate. So that's the hardmode gate. And that's gonna break probably. Boom. Control not defined. Where is that? It didn't break, but it just, okay. It took back. That's weird. So let's try to walk. Let's just try to see what happened here. So something's okay. So the X gate must have been applied because it just, no, that's really weird. So I guess we are in this case, right? So do we even get in this case? So print here. Yes, so we get in this case. That's good already. So when we are, oh wait a second. Maybe it's because I never add the edges to the system, you know. Like, so if what I should do is if edge 0 what is the entity size? Like, is there like a size, the number of elements in the entity? Yeah. Size is bigger than 0, right? Then we want to do system add edge 0, and we want to do the same for edge 1. So that for sure was missing. Okay, so now it's going to print something fancy because it's complaining about something here not being able to be printed. So to string. Okay, so yeah, so I need to get, I need to turn that into I need to cast that, obviously. What? Okay. It's, I think, not what I expected. But I see this is correct, so we have the amplitudes in here. I just need to make sure that I play with the, it's Q0 and Q1, but those don't seem to be in Q0 and Q1, and that's a problem. But it's essentially correct. So if Q0 is 0, Q1 is 0. If this is 1, this is 1. That actually, it actually worked. Okay, but it's not. Oh, that would sag though. I assumed that's what clone is for, right? Because I'm cloning these control node 0, control node 1. No, target node 0. No, I'm not doing what yeah, target node 1 I'm cloning it from. But it's almost like, you know, they don't stay in the edge. Like they should stay in Q0 and Q1. That's definitely. So what do I split Q0? I split it in the control. Yeah, okay. So it seems like I should still need to add these element. I thought clone, come on, I thought clone was cloning the thing, you know. Clone returns a shallow copy of the entity set with new the entity elements will belong to. So entity sets elements will belong to two distinct entity sets. So I should, and this one should do the entities. So I should. That's going to be a problem. Okay. That's definitely going to be a problem. I can hard code this by saying that well, like system edges, like Q, control add element control node 1, but like clone dash for you, and then I should do the same for the target. So once I clone it, here I should also say, well, for the target I want the target one to be there as well, and I think now I should do the job. Yes, perfect. That's exactly what I want to get. How can I truncate these things here? Get labels, because these I should definitely also kind of turn it into a so Python as string cast with precision. What? I'm sure there's an easier way to do that, and I'm sure that I've done these as well. Python precision to 3 decimals. Okay, but that's what I was expecting. I'm quite surprised that it actually worked. So what if I, now, for example, what if I do a, let's do another test, okay? So let's do another system that is going to be, so I'm going to do another system that is going to be I'm going to apply Control Z. Now the Z gate, the Z matrix I haven't implemented, so I actually have to implement this in here. What is the Z operator? I think it's basically I think it's just a bunch of ones and then a -1 there, or something like that. Is it? How can just, why is this so slow? Oh, there you go. So 1 0 0 -1. So the Z operator is 1 0 -1 0. Cool. So I actually need to run this. Well, maybe I should just I think gates, and because this is more like utility stuff. So, and this also is utility stuff. So it goes here. So we're running all these, and then here we actually have, you know, the beef. So it's gonna draw these, and now we're gonna give it a try with this one. Okay, so what do we have here? So we have, what? So qubit 0 is split into the 0 and the 1. Oh, look at this, it works. It works. There's a really beautiful minus in here. That's the phase that we're looking for. That's the minus state, that's the plus state. And so we have this branch here that has a probability associated to it, and this branch that has a probability associated to it. It's beautiful. Cool. Yeah, maybe I should just... oh, come on, I want to get that, like... Can I get that precision? Because this is nice. I mean, this is really nice. So, Python... set decimal precision. So what is these? Like, I don't even know if this is what I should be doing, to be honest. What the heck is this? Come on, I have done this before. So, Python right into a decimal. Okay. Format float. print float. Oh, so just format, right? So just format and then okay, so I should do these. So if I go to the print for both the both note labels. So this is basically what we want. Python NumPy complex decimal precision. Maybe there's just something I can do in NumPy to make it better or easier, because I don't think that's gonna work out the way that I expected it to work, because it's that is a complex. The state is actually a nah. Complex numbers, precision, array. I want to do this at the array level as well. Around. Okay, to the good number of decimals. NumPy around, so let's try that. Is probably the best idea. NP around, and I give it the state and I say 3 decimal positions, right? And so in here I'll also just do NP around. I think it's got to be an array. 3. This is gonna work. Around. Really? Really? NP around complex numbers. That's what I want. It's funny because I just probably spent the last 10 minutes just doing looking for these round complex numbers. How to round complex numbers. Use the around function. No, you can't. I just... There's no accepted answer. God. If are int not supported for the input types. Oh, wait a second. No. Yeah, it's all good. Okay, no, it's just the amplitude, I know. I know. That's ugly. The amplitude is 0 because it's... I'll just have to... Maybe it's complaining because it was a string. It was a string, not an int. What? NP around. Exactly. Gosh. Okay, finally. That works. Yeah, this is just 0. I gotta figure out a way to do that. Okay, beautiful. But now that works better. That looks better. That looks definitely better. And these are the amplitudes of the edges, so to say, the probabilities of those edges, right? Cool. Well, that is a... Can I take a screenshot of these? How to take screenshots in Windows? Um, how to take screenshots in Windows? What am I doing? Oh, so this is a Bell state in EHS simulator. Qubit 0 has got the 2 states, and then the 1 state is entangled with these, and so yeah. So when this is 1, this is 1. When this is 0, this is 0, baby. Cool. Yeah, we're done.